Good afternoon, everyone, or good morning, depending on where you are tuning in from today. On behalf of the sponsoring associations that you see here on your screen, I'd like to welcome you to today's Wednesday webinar. I'm Jenny Oblock with the Chemical, Fabrics, and Film Association, and I will be moderating the presentation today. Before we begin, I'd just like to cover some technical support areas. If you have any audio challenges, the quickest solution is to dial in with your phone. You can find that information in the audio section of the GoToWebinar control panel on your screen. If you continue to have any technical issues, you can always call the GoToWebinar support number, which is here on the screen. Also at this time, I would like to mention that this webinar is being recorded and it will be available following today's session. You can access that via the registration link that you use to join today's session. We will be stopping the recording at the end of the presentation once we get to the question and answer session. So today's webinar, Are You Solar Ready? Understanding Rooftop Solar Realities, is the 8th Wednesday webinar in the series since it began last year. So thank you for attending today, and if you've attended any previous sessions along the way. I would like to mention that this webinar has been approved for 1 hour of CEU credit through IBEC. So all attendees today will receive a certificate of completion via the email that you use to register. Just a reminder that all Wednesday webinars are conducted in accordance with our nation's antitrust policy. Here on the screen is a copy of CFFA's checklist of antitrust do's and don'ts. We just ask that you please keep these in mind throughout the presentation, especially if you will be formulating any questions to go through at the end of the presentation. Speaking of questions, you can enter those at any time during the presentation through the questions section of the GoToWebinar control panel. And as I mentioned, we will have time at the end with the presenters to go through those. I think as most of you know, the Wednesday webinars are held on the first or second Wednesday of each month at 12:30 p.m. Eastern Time. They are free for all employees of the sponsoring association's member companies. So when you get that information, please be sure to share it with those in your organization who would be interested in attending these webinars. Today's webinar, of course, will focus on the topic of rooftop solar. It will begin with an introduction to solar energy systems and cover the current solar market. It'll get into some of the codes that are impacting rooftop solar installation, and then it'll get into some design and integration considerations and real-world experiences, and it will finish with a future outlook of rooftop solar. So with that, I would like to introduce our two excellent presenters that we have speaking to you today. First, I would like to introduce Joe Cain. He is the Director of Codes and Standards for SEIA, the Solar Energy Industries Association. In this position, Joe leads SEIA's efforts in advocacy for development of reasonable and pragmatic codes and standards for design and installation of safe, reliable solar energy systems. So looking forward to hearing what Joe will present in that arena. Next, I would like to introduce Ron Harriman. He is a senior consultant and president of Benchmark Inc., headquartered in Cedar Rapids, Iowa. Ron has been involved in the roofing industry since 1984 and has had the opportunity to service countless multi-facility clients located throughout North America and beyond. Ron works toward a long view of roofing and helps design roof systems and management programs that consider lowest total cost of ownership, incorporating life cycle cost analysis. And I believe Ron will be getting into some of this in his presentation today. So with that, I would like to turn it over to our first speaker, Mr. Joe Cain with SEIA.
Thank you. First, you might notice that my appearance today is slightly different from the photo you saw in the bio. I just figured since I'm staying at home, why bother to shave? So hashtag COVID beard. And so I'm checking my slides to advance, and here we go. Oh, that was the bio. So I wanted to point out that in addition to being an employee of SEIA, we do have a solar vision for the first 100 days of the new administration, something you might be interested to check on. And then there's a program funded by the Department of Energy called Solar App, and it's referred to as it's for permitting expediting. So I just wanted to mention, drop the Solar App. So I'm going to, first, how did we get here? And as the solar industry has advanced and, cut costs by approximately 90% over the last 12 or so years, we now have many states and the territory of Puerto Rico that have 100% renewable energy portfolio standards. What that generally means is that the electricity produced in those states and regions are expected to be 100% renewable sources by sometimes 2045, 2050. So that's part of the growth of this. And energy codes and green codes, some of them, I will touch on a couple of them that are evolving to include solar, include energy storage, typically batteries, and charging for electric vehicles. And of course, once you've done that naturally, that can all be powered by sunlight. And then in terms of resilience, there's a point to be made that conventional PV systems or legacy systems, typically if there is a grid outage, the inverter would detect that loss of the AC signal and shut off the inverter and therefore shut off the PV, primarily for safety of electrical workers, that may be working on power lines. Part of this transition toward resilience is there is now equipment and in particular wiring that will allow those systems to remain operational with a grid outage. So that is sort of once we pair batteries with PV systems, you can expect to see more of that. I'm showing you here a couple of growth curves in terms of installed capacity. On the left is non-residential installations and forecast, and on the right is residential. Those are in terms of, when you see 2,000 megawatts, that essentially means 2 gigawatts. Now the time-traveling DeLorean in Back to the Future required 1.8 megawatts or gigawatts, just for your reference. So things are really growing. We have had some interruptions in recent years, as you can imagine. Tariffs on PV panels, aluminum and metal, steel, caused some commercial projects to go back to the financing. There's been some instability because of those tariffs. And then with COVID, we've, had some momentary pause and then back on track. So we're re-entering these growth curves, but with a little bit of disruption in the middle. So it's not quite so parabolic. In terms of corporate solar installations, SEIA published a report, the most recent one, 2019, called Solar Means Business. And there is in there an interactive map if you want to see where is the solar happening mostly. Each of those dots is a solar project. And you can zoom in on those and you can get detailed information on corporate installations. On the bottom right, you see who are the top 10 rankings as of 2019 in terms of installed capacity. And it's really growing and it's really gaining a lot of support. I'll say at this point that there are many motivators for going solar, some of which may be an environmental case in terms of, decarbonization or electrification, some of which are purely an economic decision. There's many reasons for going solar. It really is a nonpartisan thing to do. Sometimes it's just in terms of energy independence is the way some people think of it. So where do you actually find these solar-ready requirements? So in the California Building Energy Efficiency Standards, there is a section on solar-ready buildings. For residential, single-family 10 or more, so long as it does not have PV installed, that would be an exception. Low-rise multifamily, hotel, motel. And then when you go to the International Energy Conservation Code, there are appendix chapters in there Appendix chapters in the IECC are optional for adoption and are only in effect when adopted by that local authority having jurisdiction. So that's where you find the basic requirements. As far as what are the requirements, for new construction, it's typically just designation of a solar-ready zone. In some cases, it could be a percentage of roof area in commercial, or in particular residential, it may just be a certain square footage. For high slope roofs, an orientation that may be in play for solar ready. For electrical interconnection pathways and making sure that the panel has room for equipment. And then documentation is important because there are some cases we encourage new buildings, whether they are or are not going to have solar installed with original construction, to include some collateral dead load in the original structural calculations. It just helps with the seismic calculations later when solar goes on, and we're going to the existing building code and figuring out, historically what loads had on the building and what, maintaining a small percentage increase on those original loads. Any of these solar-ready provisions have exceptions to them, which are important to be mindful of. Now, the next thing beyond solar-ready is solar required. And California, in the last cycle, 2019 standards that are in effect today, came into effect January 1st, 2020. PV is now required for all new homes in California, again, with some exceptions, whether it be for shade or some other issues. And so now we're seeing in California solar required. In the next round of standards under development right now, they are working on expanding that to other occupancies. And so multifamily high-rise, multifamily low-rise, office high-rise, low-rise, educational are expected to be required to have PV on them with the new construction. The effective date of that would be January 1st, 2023. And then ASHRAE 90.1 is a commercial, an energy standard for commercial. And in a recent addenda, a requirement was introduced for solar required on commercial. It's a relatively small capacity, but it's there. Now, if we move along to other requirements that ensure the safety of these systems and quality installations, in terms of structural, there are a couple of sections in there for determining wind load in ASCE 7-16, minimum design loads. And so the commercial one that will be used most often is the 4.3. 4.4 is parallel to roof installs, which is going to be more often residential. So there are methods now for determining those wind pressures. And those are based on studies in boundary layer wind tunnels with scale models. And there's a lot of research done there. One thing that was an early observation in putting a scale model of a PV system on a scale model of a building on a turntable is some of the effects that were observed in the wind tunnel, including this detachment of the wind near the roof edge and a very large negative pressure near that roof edge, and then that reattaches somewhere later in the flow. And then this lower one is a cornering wind causing a cornering vortex. And so you can see a little heat map here that shows where some hot spots are of high wind pressure. So there's a lot of background on that in terms of wind. In terms of seismic for PV, and particularly unattached systems, ballasted unattached, the photos on the right show a couple of early research projects. The top one is calculating frictional resistance of the PV system ballast trays on a roof membrane. On the bottom is a shake table at the Peer Research Laboratory in Richmond, California. And so these studies were to figure out what kind of movement do you get when you subject these things to seismic displacements and accelerations in a laboratory setting. And that information led to some proposals that went into the building code and ASCE 7. And so that's how we calculate how these ballasted unattached systems are able to be used. And by displacement method, what it means is that you're going to go into, based on some formulas and some parameters, you're going to determine how much sliding can happen. Now, anytime roofers anytime roofers hear that the system may slide, that's immediately a concern, and it's a recognized concern that in a seismic event. First of all, these are only allowed for low seismic zones, so there should be no major ground shaking happening where these are installed unattached. But second, you absolutely need to protect the membrane and protect the roof if the system could slide. And then there are some cases where there are attachments for seismic resistance, but then ballast for wind resistance. We call it a partially penetrating system. But part of this is minimizing roof penetrations and therefore minimizing leaks. Another thing that you would observe in terms of safety, primarily for firefighters, but it could be for any workers on the roof, is access pathways and setbacks at ridges. I've been engaged in this quite a lot. Larger buildings have a 6-foot perimeter at the roof edge. Smaller buildings, 4-foot perimeter. Access pathways at no more than 150 feet, and that magic number is essentially what the fire service calls a hose lay. Clear space around smoke and heat vents is important, and roof hatches. And then skylights, not every skylight has clear space around it. Clearly, when you're on the roof, you need to be mindful about fall protection and where your feet are. But the skylights are only required to have access at 150-foot intervals typically, because even if it's not an active smoke and heat vent, there could be cases where a fire service wants to smash a skylight out for smoke ventilation. And then for high slopes, such as residential, typically access pathways to a ridge and then some setback at the ridge for vertical smoke ventilation techniques. There's always exceptions that have to be paid attention to. Particularly, there's a big exception for high slope if the fire service does not actually use those vertical ventilation techniques, and they don't need all of the setbacks and access pathways. Similar provisions in the residential code, similar provisions in the NFPA 1 fire code if you're in a state or region that uses NFPA 1. Fire classification of PV systems is a big topic of study and a big safety issue. Once you install a roof that may be Class A, the question going back 10, 12 years was, once you put the PV system on, do you still have a Class A? That was the fundamental question. These are now well developed through research and testing and codified. In the building code, it's in section 1505.9. In the residential code, it's in section R324.4. And the fundamental requirement here is that the PV system test in the presence of a roof must be at least as the fire classification that is required for the roof assembly. Now, not necessarily the same as what's installed, but what's required by the code. But in terms of warranty and all, you may wish to pay attention to what you installed and the rating. But typically speaking, the PV systems are rated for Class A or they're not. So we don't see, even though there's criteria for Class B PV system, it's just none of them are. They're Class A. And then the fire test protocol for those PV systems is in a UL standard, which is 2703. In earlier versions, it was in 1703, the same as the modules, but it has now migrated into the 2703 standard. So just to touch on that, those in the roofing industry are familiar with UL 790 and the fact that it has 3 different tests in it. For PV, we use 2 of those 3 tests, the burning brand and the spread of flame. But first, the PV module or panel itself. And in our industry, they're most often called modules, but when we get into codes, I like to have language that says panel because people often know what a panel is. And there are modules that are not panels. So in one of the standards, which is again migrated from 1703 to an international standard and become 61730, I know I'm getting kind of technical here, but the PV module itself is tested for burning brand and spread of flame. And then that module is assigned a type rating that is based on both the construct of the module and the fire testing results for the module, just flat on a roof specimen. But then for the system, you take that type-rated module and you put it on a particular mounting system, and then you do the burning brand and the spread of flame test again. And so that's how the fire classification is established. And it is in the presence of a representative roof assembly, which means in any of these laboratories, they're going to have some specimens constructed a certain way, and then the listing will show what those constructions are. Now, moving to electrical hazard, just, not a roofing issue, but a worker issue. So for fire service, firefighters, or for anyone on a roof, just to know that the electrical safety is just continually improving. Years ago, rapid shutdown came into the electrical code. Some people today don't even like the term rapid shutdown, so it's transitioning to PV hazard control. But generally speaking, voltage outside the array is limited, outside the array boundary. And then today, inside the array boundary in the 2020 NEC, there's 3 different options, one of which is essentially listing. And the UL 3741 is the recently published standard for PV hazard control, and many of the installers are going toward that. There's some other changes proposed for that section in the code as well, but it's a growing topic. Safety is essential, and there's been a lot of collaboration between the fire service and the electrical industry and PV. Okay, so other things to think about for PV rooftop installations. The first one is that typically, in order to, and mostly say going into an existing building, the PV installer for commercial projects is going to want to make sure that the warranty is still good. And so usually they will do a little research in the permitting office and find out who last installed that roof on that building, or through owner records. And they will seek out that roofer for a roofer coordination to talk about how to install the attachment points or the ballast or whatever it is in order to maintain the warranties. Sometimes those people cannot be found, so it complicates things a little bit, but that is a first position of trying to find the most recent roofer. For low slope roofs, the cover boards certainly help with fire classification, especially if we're trying to attain the Class A. They also help with moving equipment across a rooftop, such as PV panels or even the ballast blocks that are very heavy. A lot of times you'll see these carts with some big, moon buggy tires on them to try to minimize, or not damage the roof. But again, cover boards and a path of travel help. The ballasted unattached membranes. Now, they work the best on fully adhered membranes. As some will even say, FM Global, for instance, they want to be a little extreme on this and say don't do unattached on mechanical membranes. But certainly, I hear different. I hear sometimes that very large spacing between lines of attachment. So you want to be mindful of ballasted systems on mechanically attached membranes. And then, of course, we should protect the membrane, and we should be mindful of sliding. Now, speaking of FM Global, they do have their own property loss data sheet. This is based on just simply claims for property loss and the research that goes with it. And they have, so this document is not code, it's not a requirement. However, in some cases, you find that, you can be discussing this in terms of insurance. And one of the things that is a little bit surprising, it was surprising to me the first I heard it, is that the membrane in a mechanically attached membrane, under some conditions where the internal pressure in the building is very high, can puff up and billow. And here's an example in a test setup for FM. But if you have ballast blocks, you can kind of visualize how that may influence the ballast blocks. So here's a kind of bringing it all together as far as who does what. The manufacturers of the PV modules or panels themselves, they do their performance testing, they do their fire testing to establish the module type rating. It's important to know that even though the standards are UL standards, that any nationally recognized testing laboratory can do this work. And then the manufacturer of the mounting system will take that type rated module, put it on, and test it for fire classification. They often, most of the major manufacturers have got wind tunnel studies where they have gone to a laboratory and put it on in a boundary layer wind tunnel. The deflectors help with fire and wind. And then for a particular project, this is kind of the important part. The mounting system manufacturer typically has a civil or structural engineer that determines the wind and seismic, specifies the attachment, and determines the structural loads, and then hands them off to the installer's engineer. And then the integrator or installer is going to put together that information and going to take it to their own engineer, who will take those loads, hand it off from the mounting system, and check the building for that. If something doesn't check it out, they can send it back, reconfigure the system, do whatever. And then once again, the project construction manager is going to seek out the roofer for a roofer coordination. So that's kind of the layout of how everything all comes together. And at that point, I'm just going to hand back to Jenny for next speaker.
Thank you, Joe. And I knew rooftop solar was an attractive and growing trend, so it was interesting to see some of those forecasts, and then of course the code bodies that encompass some of that in their requirements. And now I'd like to turn it over to our next speaker to share his experiences with rooftop solar. I introduced him not too long ago, Mr. Ron Harriman with Benchmark.
All right. Well, thanks, Jenny. I appreciate the insight, and thanks, Joe, for sharing your insight and your knowledge. I can tell that I'd like to get your number, and so we could connect and really talk some specifics. So I'm really glad to be part of the Wednesday webinar, and I noticed that you guys have emphasized the whole idea of thought leadership with your approach to these Wednesday webinars. And I think that's a great thing, and I'm glad to be a part of it. And if anything, I want to kind of dwell on that idea of thought leadership. I might disappoint some of you by not going into a lot of detail on particular issues, but I do want to help sponsor a way of thinking. So hopefully that's in alignment with your goals through this pandemic period and this time of virtual work, where Wednesday webinars are a great way to sharpen the saw and to think about how do we develop ourselves and our organizations, our industry around thought leadership, in this case, specific to rooftop solar. So rooftop solar, I think a common question is your roof solar ready? But I don't really want to talk so much about is your roof solar ready? I want to talk about, are you solar ready? So let's get rolling here. So here's kind of the outline I was provided in terms of objectives, where we want to head. So just kind of give you a high level view of where I want to head today. I just thought I would share some of our experiences when it comes to rooftop solar. And that could come in a couple of different areas. One where there's an existing roof that has solar on it. And we might be looking at doing an assessment, or what is the condition of the existing roof and solar system. Likewise, we may have an existing roof when the client is considering solar. That's becoming a more common scenario for us. Probably one of the funner places to get involved is when we have a re-roofing project and the client is considering solar. So we want to think about that and make sure that we're ready for that. And new construction, I'm not going to talk a lot about that today because it's so similar in terms of way of thinking around to re-roofing. So I'm not necessarily going to spend a lot of time on new construction, but I do think of it as being very similar to the mindset that we use when we're thinking of a re-roofing project. So those top solar issues and how they're best solved. I'm just telling you right now, you're probably going to be disappointed, but I am going to give you something to think about. All right, so hang in there with me if you would. So anyway, real quick, for those that don't know Benchmark, we're a roof and pavement consulting firm. And if nothing else, I thought on a February day, it'd be good to see a picture of some flowers, and also give a good consultant always lets his clients know that Valentine's Day is just around the corner. So you've got a few days to get ready for that. So that's a picture of our parking lot in Cedar Rapids back when we used to have cars in it. We're working remote just like the rest of the marketplace these days, but really we work nationwide and hopefully provide an unbiased and technical expertise when it comes to areas of roofing and paving. And this is our team back when we didn't have to wear masks. So wouldn't it be nice if we could get back together sometime soon? I'm sure you're all feeling that same way. But there's so much to be gained from this virtual world, even in terms of teamwork and collaboration. So Benchmark, about 115 people, amongst those professional engineers, registered roof consultants, registered roof observers. So enough about Benchmark. Let's dive right into our experience with rooftop solar. And the first area being those cases where we're being brought in, there's an existing roof and it has a solar system on top of the roof. And so I've got a retail example, an industrial example, and then also a commercial example. This one's not too far from me today. It's probably within about 2 miles of where I'm calling you. It's in southern Arizona. The facility is about 17, the existing roof, is 17 years of age at the time we looked at this. Likewise, the solar panels on the system were 17 years. So at the point of roof replacement, 17 years ago, they installed the solar system. At that point in time, they utilized about 26% of the roof area for panels. One of the things I definitely see increasing these days is the size of the systems are being increased to take on bigger and bigger pieces of the roof. So here's the closer view of the panels themselves. It's a ballasted system with concrete paver blocks providing the ballast. One of the things that I would touch on as a lesson learned here, when I think of 15 to 20 years ago, I didn't look it up in particular, but I went to the NRCA in Las Vegas, and I left there. I reported back to my team when I got home and said it wasn't really a roofing show; it was a solar show. And I think that kind of revealed a little bit of my maybe negative attitude. But one of the things that now that we have experience, and some of the products being promoted back at that point in time are no longer even in the marketplace. But one of the things we've certainly learned is it's here to stay, and it's actually growing, and I'm quite pleased about that. Just to drill down to some detail, one of the problems that existed on this 17-year-old membrane, and in this case, I looked at the roof myself, and I did recommend roof replacement at that time. So the roof was 17 years of age, and I was recommending roof replacement. So here you can see, zeroing in on the rack system itself and the rubber blocks that were installed on top of PVC slip sheet on top of the PVC membrane. One of the takeaways from that was, I'm going to call it an incompatibility between that rubber block and that PVC membrane. We saw where it affected both the rubber and the PVC, and not in a good way. So a little bit of a nitpicky lesson learned there. Likewise, some of the components, the more detailed components, were showing their age. Obviously, wherever you rely on caulk, we've known that from a roofing perspective forever. The sealants themselves are not probably going to last as long as the rest of the components. And in this case, I think it's an example where, I looked at it and I thought, well, what happened here? Do we have an electrician trying to do roofing work, or do we have a roofer trying to do electrical work? The details matter, and some of the components are going to require maintenance and service during the life of the system. In this case, what you're looking at, I switched buildings on you. This is a building in Massachusetts where we were hired to do an assessment of the roof. This light manufacturing facility, you can see in May of 2020, when we looked at the roof, looked at aerial imagery, and the solar system is more or less confined to the upper bay of the roof on the left-hand side. You can see that going back through some Google images, we could see that same building in March of 2017 on the left, didn't have any solar panels. That we were able to piece together, even though the facility people in the that were managing the building had changed and there had been turnover, we really had a lack of good information. But we were able to ascertain that the solar system was put up there when the roof was about 9 years of age, and sometime in late 2017. So this is a plan view, roof plan drawing that illustrates the blue kind of shaded areas being the panels themselves on what we call roof area A and roof area B. Some things that, so you can see the aisleways that Joe referred to that go to each of the HVAC units. And then some of the other things that we're pointing out in our CAD plan here are the shaded areas being actually areas of wet insulation, some areas of ponding water, etc. I'll just kind of zoom in on roof section A. One of the things that I'm going to point out, at least that I think is worth takeaway, we've got some wet insulation that's revealing itself along the perimeter. If you follow my cursor, these areas here along the perimeter are indicating, obviously with an infrared scan, we had a very limited viewpoint of the roof to do a traditional moisture survey. But we could see some moisture along the perimeter of the panels, between the perimeter of the panel and the perimeter of the building. And unfortunately, these red X's or plus signs on the drawing indicate active leaks. So there's an active leak within the solar array, which is not a good thing. I can tell you, and most of you probably know this, but if you have a leak within the body of the solar array, it's going to be a very time-consuming, very expensive process to try and find that leak. So definitely that pain is something we need to think about before we put solar on a roof. Here you can see an infrared scan where you can start to see some of the streaking as it moves to the left side of the drawing, being the perimeter of the building where the water is accumulating along the low eave detail. But the streaking indicate, okay, we've got water traveling from underneath. We've got water entry or roof defects occurring back underneath the panels. Not a good thing. And Joe touched on wind and seismic. To me, the easy part ought to be how do we design our roofs and to keep them, performing in wind, and how do we design the roof panels? It can be done. And I think, South Florida or along the coastlines gets most of the emphasis when it comes to how do we design for wind, and where is it most difficult to design for wind. But this building in Cedar Rapids, Iowa, so just down the road from our office, in August of 2020, so less than a year ago, we had a storm blow through of major magnitude and obviously just completely destroyed this ballast assembly. So we do have to pay attention to attachment. There's a lot of engineering that needs to be considered, and I know Joe just kind of whet our appetite when it comes to the seismic requirements and structural dead load requirements. We've got to get that right, no doubt about it. So I don't mean to make light of any of that today. So what are some lessons learned? First of all, let me just say that I was a little bit of a naysayer. Back in 2000, so 21 years ago, when I went to that quote roofing or solar show, and people are talking about, one of the things that was a no-brainer to begin with is that you wanted to align the life of the solar with the life of the roof. And I'm thinking, well, every time someone says that it will last 20 years, I've got something going on my head that says, has it been here for 20 years? Are we sure it'll last 20 years? And in this case, like I just showed you that South Arizona retail example, we got to see those panels when they've been in place for 17 years. The panels were in great shape. So my confidence has been increased in terms of one thing, and that being these panels, and I got to believe the ones being installed today are going to be better than the ones installed 17 years ago. So let's put our faith in the idea that the solar can last 20, 25 years So we can remove that concern. Foot traffic. Boy, we're seeing a lot of issues associated with traffic because the roof traffic tended to fan out across the building to go to HVAC units and around the perimeters or whatever the case may be. Now it's all being concentrated. So it's money. It's a good investment to think through and to invest in traffic protection. Compatibility, that's easy. Caulking, that's easy. Like it or not, if you got a leak, you're gonna have a miserable experience. So you need to treat that solar array just like it's an overburden system. If we were designing a plaza deck where we were going to put pavers and various overburden systems of plants and all of that, we would think so long and so hard about how to perfect that roof. Well, I want you to think that same way when we're putting this overburden system on top. So those are some of the lessons learned. I would add my personal preference, and I don't mean to, cast disparaging remarks on anybody's engineering, okay? But I keep the solar panels back from the perimeter. I'm seeing issues where they're trying to maximize how many panels they can put on that building. Keep it away from the perimeter. We're seeing, I'm going to say, fall protection issues and wind issues. And as Joe showed you, the wind uplift forces, particularly the negative uplift forces, are concentrated at the perimeter. So why not move back from the perimeter? We're just asking for trouble when we go clear to the perimeter. And I think we've got more to learn too. What's the effect? Is the roof membranes being protected by the solar array because they're shaded from the sun, so we don't have UV load? Or is it being advanced and aging because of the heat? Or if we have the panels up to a certain height, we don't even have to worry about the heat. I think the roofing industry can really go to work on this one in terms of studying the effect on what happens to our roofs underneath these panels. So let's switch to having an existing roof and the client's considering solar. So I'll jump right in, kind of show you a way of thinking about that. And this is just an old-fashioned deterioration curve, some of which I think is a bit sobering. What I'm showing you is on these two axes, the condition, vertical axis, the age, horizontal. I'm going to say maximum service life, 25 years. That's certainly not maximum, but it exceeds how long most roofs in the low slope marketplace last today. In fact, I'm showing the typical curve where the average low slope roof being replaced is and we don't have great data on this, but it's somewhere in that 17-year time frame, which is horrendous. But certainly it's an issue if you're installing a 25-year panel on a roof that is going to last 17 years. So I drew a red vertical line there about year 5. In our way of thinking, you probably lost the window of opportunity to consider installing solar if the roof is anywhere older than 5 years. So it has to be less than 5 years of age. This is just a live example, just a couple of months ago, back in December, we took these photographs. This is a 2-year-old roof. The roof, new construction at 2 years of age. The building was built with the idea that they're going to put a solar array on it. It's a big building, pushing 1 million square feet. So the roof is 2 years of age. It's under warranty. It's never leaked. Thankfully, the client had us come in and do a thorough inspection of the roof before the solar installer arrived. And we found literally hundreds of problems with the roof, all of which easy to fix. But if the solar installer had just gone to work, put panels down, it would have revealed itself someday. This roof construction it's an induction welded system. We had some scuffing, we had some seam issues. We also had a lot of punctures. And so it's like, how could the roof not be leaking? Well, the construction, we had that mechanically fastened system, a couple layers of ISO, but then we had an air barrier, which is actually a slightly waterproof type layer within the system. So the water entering this roof system was not showing up in the building. So they had a false sense of security in terms of the roof condition itself. So boy, if you take anything away, it's the emphasis on quality before you install the roof or the solar system on the roof. Think of it just like it was a plaza deck. In a plaza deck, you'd probably be doing water testing, flood testing, all kinds of things to make sure you got it right. Well, approach it with the same level of care. So a couple of cross sections. You know, this I'm going to say is kind of a light duty roof, but we see it all over the place. You know, 2 layers of ISO fastened, you know, light duty membrane. I'm going to say that's not solar ready from a just physical construction standpoint. I've added a weight chart over here. It's one of the things that we want to consider. If a client's thinking about putting solar, let's add up the weight of the components and compare it with the design of the frame or the building. So believe me, we cannot, you know, just fly by that point. Permitting, when you're going to consider not just a roof permit or not just a solar permit, but you're going to do both. And I had a contractor tell me that they consider themselves to be a permitting company with a construction arm. Getting permits is difficult, especially if you're in Florida or California. It takes good engineering, a stamp most likely, but you really need to tune in to the design of the building from those perspectives. So if we enhance that kind of light duty system, we might think about adding a cover board. In this case, the cover board is fastened. We probably beef up the membrane to a thicker membrane or perhaps to a modified bitumen membrane or built up bituminous assembly. I'm not here to talk so much about the pros and cons of any particular membrane, but again, this one's getting closer. I think you really would consider this cross section to be solar ready, even though some maybe not quite preferred. And then the next one is probably getting a little bit more officially solar ready in a preferred way, that we've got that same ISO, but instead of fastening the cover board, we're adhering the cover board and then it's adhering the membrane. Again, whether it be a modified bituminous assembly or a heavy duty EPDM or heavy duty thermoplastic membrane. Again, add up the weights. I didn't add cost in here because, hey, there's so many variables when it comes to cost, but when we would get down to a particular product, that's the type of thinking we want to walk through is, okay, what's it going to take to get the roof design beefed up to the point that it is officially a good candidate to be putting solar on. And this, interesting, as Joe alluded to, FM can come into play. Well, if you're FM insured and you have and the building is in Texas or somewhere where we have a very severe hail area, we've got to do some things just from a roofing perspective to make that roof compliant with FM requirements. Well, likewise, that heavier duty cover board, in this case, it's a 5/8 cover board being one potential cover board. I know there's more than one, and a real heavy duty membrane. Well, that automatically puts you in a good solar position. So you're kind of killing 2 birds with 1 stone. This is kind of a favorite story of mine, and I'm just thinking in the spring, I'm going to once again get a call. This client, they have both, let's call it a roofing team, and they have an innovation team that's considering solar. And the innovation team is not talking to the roofing team, okay? They are, I don't even think they know that each other exists. The solar team desperately wants to put solar on this building. The roofing team wants nothing to do with it. So it's like, okay, how do we think about this? For one, it's a 22-year-old built-up roof. We've done an infrared scan. It's got random areas of wet insulation. You can see a little bit of the age-related deterioration in the alligator surfacing. Just not a good candidate because of many factors. But if I could advise, the solar community, and I know that most of our audience today is from the roofing community, but the solar community, don't force the fit, okay? If we want to be successful together, we can't force the fit. And this would be a complete force fit. It's like, okay, think about it. Is the roof less than 5 years of age? No. Is this roof in good condition? No. So therefore, would we consider it to be solar ready? No. So don't force the fit, okay? I think we'll all get along better if we can agree on that one. So again, think of it as a little bit of a flow chart. Are we going, you know, is the roof less than 5 years of age? If not, you knockout punch. Is the membrane good condition? Not just good condition, it's got to be like perfect. You want to really emphasize quality. Systems, you know, is the roof construction, that composition, is your building capable of holding the weight? And then is our roof really designed for it? If that's the case, then we're all systems go. All right. So, all right, here we're going to go into re-roofing. Are you ready for solar? That's kind of the, you know, if you think of it, an architect getting ready to design you a new home, they'll first of all start with a programming mentality. I remember I worked with an architect to design our home, and so he asked me, okay, when you get home from work, what you know, what do you do? Where do you enter? What do you have in your hands? I mean, he asked me all kinds of questions so that he was ready to design the house for me. Well, likewise, at Benchmark, and I'm just going to show you an example of the way that we approach it. If we're going to re-roof a building or help a client with a new construction, either one, we're going to walk through a bit of programming, design review summary, we call it. So here's just an outline of a re-roofing project. So we want, if success is going to happen, we're going to have to think about these things. Okay, look at the existing roof or new construction. What's the history? Talk about the components and their condition. Then, okay, all the way down through these system requirements, the building code, the energy, the wind uplift, you know, fire, wind, hail, all that stuff. Insurance. How long do you want it to last? Warranty. Are you really interested or motivated by warranty? Some are, some aren't. And we're not doing this roof for my benefit or Benchmark's benefit. I think it's interesting. This audience today, I think hardly anybody here is on this webinar because you're thinking about putting solar on your own roof. You're talking about doing it for somebody else. So you've got to tune in to what is important to them. You know, let's talk about safety, obsolete equipment, chemical exhaust, you know, all the way down through those. Slope, it's huge. But then sustainability. Wow. This to me is a way of thinking for the roofing industry. When we have to start not only thinking about our traditional roofing issues, but we've got to start thinking about sustainability, clean energy, our clients' green goal. What do they want to do from an energy efficiency standpoint? Solar is just a subset of that entire big picture viewpoint. Waste, you know, materials management, water management. Start thinking that way. I honestly feel this is a way for the roofing industry to get aligned better with our clients' goals. You know, it's sometimes I think we're designing roofs in a vacuum. We're doing it because, okay, this is what it takes to get a warranty. Well, we're selling our clients short with that mentality. And solar gives us a better opportunity to tune in to what the client's trying to do. And just a couple examples of that. Here's Walmart. Whether Walmart's a client of yours or not, you can go right to their website and find what their approach to renewable energy is. And they have an incredibly high objectives. And they're trying to be a good example in the marketplace, and not just the United States of America, but throughout the world. So those are goals we need to start tuning into. We need to listen and think about them and not ignore them. Target is a real leader. Look at that goal, their goal, committing to source 100% of their electricity from renewable sources by 2030. That's only 9 years from now. So man, you got to make some tracks if you're going to help them get that done. So I know I told you I was going to disappoint you. If you came here to listen to me talk about the solar issues, I'm not here to talk about the thickness of the membrane or how we attach the panel. Okay? I don't think, you know what, that's the easy part. Yeah, we got to have structural capacity and seismic and all that stuff. But if you want to be successful, let's change the way we think. Big picture game plan. Okay, I'm going to just walk you through some examples. Does your client, what are their core values? Maybe their mission statement, their sustainability objectives, et cetera, their core focus. Where do they want to be 10 years from now, and what's their strategy to get there? So then you got to think about, okay, in 3 years, 1 year, next month, what am I going to do? Issues. Okay, here's what I think my somewhat passionate plea here today is: don't start with the issues. If you're thinking about the issues, I'm going to call that small thinking. Okay, if we're going to be successful as an industry on how to solve those issues, be really good problem solvers, here's what we're going to have to do. We're going to have to go back to the top. You got to connect with what your client's trying to do in a big picture way. If you do that, you're going to be far better off handling those issues. So if I could do anything, you know, I'm just really excited about solar when it comes to roofing. And I think there's some integration, not only integrated systems, but there needs to be a way of integrating our thinking. Solar team, roof team, get together, understand client, understand what they want to accomplish, then we'll be able to solve problems. Well, thanks for putting up with me here today, and I'd be glad to answer any questions, and you guys will have my number if you ever want to reach out. All right, thank you.
Great, thank you, Ron. Really great to have your consultant experiences to share with us today. We have one more section to get through on the future of rooftop solar, but you can continue to enter your questions, and we'll have a couple minutes at the end to go through those. So just moving into our final portion for the webinar today, we have a couple minutes. Wanted to get our presenters' thoughts on the future of rooftop solar. So Joe has joined us back here. And just to kind of cue up this discussion here, since we have roofing materials and systems manufacturers here listening in, just wanted to get both of your perspectives on maybe any of the areas of collaboration or opportunities for manufacturers, or if there's any issues that may need to be tackled to continue to see growth in rooftop solar. So Joe, if you can lead us off, and then Ron can follow with some of his thoughts.
Sure. Just the first thing I would say is that it's only going to get bigger, and the growth curve is pretty amazing. And what we're seeing, you know, in some states and in some local regions, is a move toward clean energy, a move toward electrification, even. And you know, to me, the buildings of the future have solar and batteries and EV charging, all powered by sunlight. So the demand at this point, we're seeing consumer-driven demand, as well as sort of institutional or government-driven demand. And in terms of issues with roofing systems, you know, clearly there are some identified risks that the solar industry is aware of. We have at SEIA consumer protection services, and if there are issues, you know, there are ways to report to SEIA. And what we're striving for in codes and standards and criteria and installation criteria is just continual improvement. So there's always opportunities to learn, and what we should be doing is seeking continual improvement always. Thank you.
Yeah, I would echo Joe. I think it's only going to get bigger. In fact, you know, many forecasts you read it'll be 10 times bigger than it is today. So I think, okay, if we're going to go down this road, let's do it well. I'm just so pleased that it is not being driven simply because of tax incentives. This is corporations going along with this and saying, hey, regardless of the tax incentives, we're going forward. So I think we're going to see an increase in this, so we can, you know, do it and do it well. And I hope that by that integrated approach that we have a nature of doing it better all the time. I think we'll be, you know, see an improvement in the way that they work together.
Mm-hmm.
Great, thank you both for those thoughts on where you see rooftop solar heading. So we do just now we will transition into the question.